Okay, now that we are experts on ping, let's run some trace routes and be done with this lesson. Let's start with a simple trace. So the syntax, you should probably know this. Windows is using the command traceRT, no spaces, no dashes, traceRT, space, followed by your intended destination, whether it's the IP address or a fully qualified domain name that you want to trace. Unix-based systems don't use traceRT syntax. They use the command called trace. Uh, little details. So our first trace is complete here. You can see we were tracing Google DNS 8.8.8.8. By default, we will try to run 30 hops, no more than 30 hops. In this case, didn't take anywhere near that much. So what we should notice, first of all, Windows tries 3 echo requests with time to live set to 1. Then it follows with 3 echo requests with time to live set to 2, and so on, right? So Windows by default tries 3 pings, 3 echo requests per hop. In this case, we got to the destination in 11 hops. So we tried every hop 3 times. That's why you'll see 3 millisecond values on each hop. We already discussed milliseconds when we looked at pings, so no need to repeat that. So on the left, you see the sequence number of your hop, followed by the approximate time that it took you to, again, round trip. Remember, this is round trip. Took you to reach that hop, followed by the IP address of that device. Mostly these will be routers or firewall. Layer 3 devices that can route. And at the end, you'll see your ultimate destination. Most of these IP addresses automatically resolve to fully qualified DNS names. So again, Windows initiative, your computer will try to resolve these IP addresses simply because the DNS names may be a little more meaningful to you than IP addresses, so it's easier to read and easier to understand what you're actually staring at. And when you look at trace routes for a while, you will get the gist of it. You will learn how to read most of these fully qualified domain names. They become self-explanatory in most cases. Like here, we can see that we're starting from SI stands for Staten Island, New York. Residential, RES, right? Residential, RR.com. RR stands for Roadrunner. Roadrunner, if you recall, it was a product, residential internet product of Time Warner, which is now part of Charter Communications. So we could see that, we could tell that the first, actually a good half of our hops remain on the Time Warner or Spectrum, now it's called, which belongs to Charter. So a good part of our trace route stays within that Time Warner network. And we are also staying in the New York area. You see, almost every hop says NYC, NYC. Whatever goes before NYC, this is usually the router name and the interface. um, where this IP address is configured. We don't need to understand the exact details, but it gives us a general idea where we are. We know that from my location, we are tracing through New York using Time Warner Network. Here we have Newark, New Jersey. For some reason we went from New York to Newark, New Jersey, and then we went back to New York again. Go figure. And we're staying in New York. And that's it. And we jump directly to Google. So there is a direct, most likely there is a direct connection between Time Warner and Google. I don't see why there wouldn't be. Both are big enough. So they're peering with each other directly. No other companies are involved here. No other ISPs are involved here. Only Google and Time Warner. Okay, pretty simple, makes sense. Hop number 10, very important, extremely important. I will refuse to proceed before we understand hop number 10. I can't stress how many times people told me, oh, we see these asterisks on hop 10 because we're getting packet loss here. Asterisks indicate lost packets. Well, no. The fact that we have 3 asterisks means that there is a device here. There is a layer 3 router. It's live. It's passing our traffic. But it has ICMP disabled. This device, whatever this is, could be a firewall. It could be a router. It has ICMP disabled. This device is not allowed to send us time exceeded messages. ICMP time exceeded message. This device does its job. Its primary job is to route, to forward our traffic to the destination. It does its job, but it's not allowed to give us any ICMP messages. So we're not getting any messages from this device. We don't know what IP address this device has. We don't have any latency values, millisecond values, but we know this device works. How do we know this device is live and it works well? Well, look at the next hop. The next hop is clean and healthy. Had the device on hop 10 not worked, we would not have received any output on hop 11. So very important to remember. If you receive only one asterisk, like say here for example, that would have been a different story, and we will see them. We'll see them in our next trace routes. Let's try. This was too easy. Let's try something more distant. Australia.gov.au. Let's try this. Okay, the trace will run a little longer, but we can start discussing it. So this is somewhere in Asia Pacific, I would assume. We start, just like in the previous trace route, we started in New York on the Roadrunner network, Time Warner network. Then we transitioned to something that didn't resolve to a fully qualified domain name. And we can try to look it up, right? If it didn't resolve and you're curious about what it is, you can always try and look it up on Aaron's website. Aaron.net is the website for North America, where you can look up the owner of the IP address. Or if the owner is not in North America, then this website will tell you where to go to look them up, whether it's RIPE or Africa or Asia Pacific and so on. So we will cover that in our future lessons in greater detail, the internet infrastructure, stuff like that. Cool stuff. So this IP address belongs to Charter Communications. Okay, nothing exciting. So pretty much this half of the Traceroute belongs to Charter Communications, and then we hand off to PCC Global. PCC Global is an Asian telecom provider, and that's it. You won't see a response from the actual website that we're trying to trace, 54.252.130.223. You don't get a response from them. Why is that? Well, because they don't want to, right? They have ICMP disabled. Simple as that. So we can trace as close as possible to them, but then we don't know where the actual website, on which hop the actual website is. We don't know if the website, if the destination of our trace is on hop 11 or 12 or 13. We don't know that because after hop 10 we get no response from anybody. But what we do get here, we see where we cross the ocean. Okay, from the United States we're going to Asia Pacific somewhere, and you see how dramatically our latency increases between hops 7 and 8. We go from 2-digit numbers to 3-digit numbers. That's where you cross the ocean. That's where your traffic traverses a submarine fiber optic cable, and your numbers, once they turn to 3-digit numbers, they will stay in 3 digits. These numbers are pretty consistent with the destination that we selected. I wouldn't expect to ping something in Japan, China, Australia, and receive a double-digit ping. Actually, upper 100s, lower 200s would be pretty normal for such a great distance. All right, let's try to trace something else. Okay, so we're tracing Yandex.ru, a Russian website. Again, obviously starting in the same New York area, Roadrunner network. Then a couple of hops refuse to respond. Okay, they're not allowed to talk ICMP with us. And then, boom, on hop 8, we see level 3. Washington level 3. I'm not sure if this is a state of Washington or what Washington they're talking about. Level 3 is a huge tier 1 internet provider, and from that point on we cross the ocean and we get to our destination. And two devices on this path refused to talk ICMP. Okay, makes sense. Let's try something else. And by the way, we can add an option here, minus W space, let's say 50, followed by, I'll explain this in a second, followed by let's try this, British website, pepperpig.co.uk. Minus W50 limits our waiting time for unsuccessful echo requests. So this, I call this an impatient traceroute. It will go a little faster, and we should see more misses. We should see more asterisks. Just because we're impatient and we're going fast. Well, it's still running pretty clean, which means the networks are in pretty good condition. Yeah, no missed packets, no packet loss. Okay, nothing exciting in this traceroute, but I wanted to check the owner of this IP address, the last one. So if I go to Aaron, oops. So no, it's not in England, even though it's a British company. Peppa Pig was born in England, but this IP address belongs to Shopify, and this company is incorporated in Canada. So this is a Canadian marketing site. So we just learned something about Peppa Pig. They're relying on a marketing company to host and maintain their website. Okay, that's where traceroutes get useful. You can learn a good deal of information about the company or the business that you're tracing. You can find out where they're hosting, what internet providers they use, what locations they're in, so it can get pretty interesting. Let's try one more. Let's try Netflix. We know where Netflix is hosted. It's hosted in the Amazon cloud, and we should be able to confirm that right now. I wanted to catch a lost packet. I really wanted to catch that to show you. So this one is a legitimate packet loss, right? Out of 3, we lost 1. But remember, we're running the impatient impatient traceroute. We set our wait time to only 50 milliseconds, so our traceroute runs a little faster. Marginal values may get discarded. So let's see if Netflix resides on the Amazon network. Let's look up its 99 address. And it belongs to Amazon. Confirmed. Again, nothing fancy or unexpected here. I press Ctrl-C to stop the traceroute because it will continue until it goes through 30 attempts, 30 hops. So we start in the Roadrunner network again, and we hand off to the AWS network. 3 devices running in stealth mode, hiding from our ICMP requests, and then device number 11 revealed itself, and then got quiet again. So we don't know where the actual destination is, on which hop it is.